Welcome to Wafu TV. Thank you for being there for today's lesson. Today we are going to look at factors, common factors, and highest common factor. Last lesson we looked at multiples, common multiples, and the lowest common multiple. So today we've shifted and we want to treat something new. Without waste of time, what are our objectives for today? Today, we want to be able to list factors of numbers by the end of the lesson. Equally, we want to be able to identify common factors of numbers. And lastly, we want to be able to calculate the highest common factor or the greatest common factor of given numbers. Before we go into calculating and identifying these factors, what are factors? Briefly, a factor is a number which can divide another number, of course the bigger one, without a remainder. Please take note. A smaller number which can divide a bigger number without a remainder. These are factors of a number. Equally very important is the fact that in factors of numbers, 1 and the number itself are always factors of a number. For instance, if you were to take factors of 9, then 1 and 9 will be factors of 9 in addition to other factors. Example 1, what are the factors of 12? Before we list the factors out, I want us to do some rough work this way. 1, 2, 12 divided by 1, 12 divided by 2. I want us to end here for reasons I will explain later. 12 divided by 1 will give 12. 12 divided by 2 will give 6. 12 divided by 3 will give 4. 12 divided by 4 will give 3. 12 divided by 5 will give 2, remainder 2. 12 divided by 6 will give 2. 12 divided by 7 will give 1, remainder 5. Let's just end at this level. We have said here that factors of a number are numbers that will divide a given number without any remainder. So if you look at this, you will realize that 1 divide 12 without any remainder, 2 equally, 3, 4, 5 does not because there is a remainder here. So 5 is not there. 6 will divide without the remainder. 7 is not because there is a remainder. Why did I say we should end at the level of 6? Half of 12 is 6, and any number that falls after 6 or after half of a given number will divide with a remainder. So there is no need to try finding numbers that are above half of a number that can divide that number because it will come with a remainder. So from this, we can identify our factors here, the ones in circle. Factors of 12 will be equal to 1. As we said, it always starts with 1. Then there is 2, there is 3, there is 4, there is 6, and it ends with the number itself, which is 12. Whether we did not mention 12 here, you should know that it starts with 1 and the number itself. And the number itself we are talking about is 12. 1 and 12 are always there, and you can identify these other factors. With this said, let's move to the next example. Find the HCF of 20 and 24. Please pay attention and make sure you are able to identify the common factors in this one and equally the highest common factor. Let's list the factors of each of these numbers. 20. Using the method we used in calculating the factors of 12. What are the factors of 20? They are 1 is there. This is an even number, so 2 is there. 3 is not, because if you add this, it will not give you a multiple of 3. 4 is there. 5 is there because the number ends with 0. 6 is not. 7 is not. 8 is not. 9, 10, which is half. And after half is the number itself, 20. factors of 24. We always start with 1. And if this number is an even number, 2 should be there. If this number added together gives a multiple of 3, means 3 is there because this plus this is 6. Then we have 4 as well because 2 and 3 are factors of the number. Remember the test of divisibility. So 4 is there, 5 is not because the number does not end with 5 or 0. 6 is there, 7 is not, 8 is there, 9 is not, 10 is not, 11, 12, and since 12 is half of this, the next number should be 24. So if we have identified this as factors of 20 and 24 respectively, then common factors will be equal to what we have both here and here. And these are 1 is up and down, 2 is here and here, 4 is here and here. That's it. Our common factors will be 1, 2, and 4. 1, 2, and 4. Therefore, highest common factor will be equal to, what is the highest number here? It's automatically 4. The essence that I want to identify here is to be able to identify the common factors and to be able to identify or list out the factors of numbers. Let's move to the last question, which of course will help us to use factorization to find the highest common factor. Example 3, calculate the highest common factor of 12, 18, and 24. Okay, let me take us back to our previous example. If you look at this example, it takes space, it takes time. What can we do to simplify and make the solving or the calculation of highest common factor easy? Is by using prime factors. I remember having mentioned the phrase prime factors a couple of times, and that's what we're going to do next time. Follow up and look at what it's supposed to do. You create columns and rows, and in these columns you fit in 12, 18, and 24. Of these three numbers, which prime number will divide all? I want to repeat, which prime number will divide all, or which factor will divide all these numbers without a remainder? Not one of the numbers, not two, all the numbers. All are even numbers, so 2 will divide. 2 divides 12 6 times, 2 divides 18 9 times, and 2 divides 24 12 times. Create another row. At this level, which factor will divide these three numbers without a remainder? All the numbers, not one of them. Now if you take 2, 2 cannot divide 9 because 9 is an odd number. So we move to the next factor, next prime factor, which is 3. 6 divided by 3 is 2, 9 divided by 3 is 3, and 12 divided by 3 is 4. Create another row. At this point in time, you realize that 2, 3, and 4, we don't have any other prime factor that can divide all the numbers without a remainder. At that level, we are going to end there and multiply our prime factors. Therefore, H.C.F will be equal to 2 times 3, which is 6. That is it. I believe it was easy for you to follow. I want to make this difference, please. When you are calculating the HCF, the prime factors that you find here should divide all the numbers. For HCF, it should divide all these numbers without a remainder. But for LCM, it divides either 1 or 2 or all the numbers without a remainder. So that's the difference. If you benefited something in our lesson today, click the subscribe button and also hit the notification bell for more of our lessons. Thank you for being there, and see you in our next lesson. We'll be talking about prime numbers. See you.